Okay, today we're looking at what we call I and J notation. So I is a unit vector, so it's a vector of length 1 in the x direction, and J is defined as a unit vector in the direction of y. Alright, so we use those to indicate a vector. So what that means then is that vector R would be written as xi plus yj, where x and y are elements of real numbers. Alright, so for example then, we have vector, so vector A equals 2i plus 5j. That means that we're going 2 in the I direction and then 5 in the j direction. Alright, so let's look at an example. Okay, so here we go. We'll draw a vector to represent A, which is 3i minus j. So if we have our axes here, so the I and the j point in those directions. So we've got 1, 2, 3 in the I direction and -1 in the j direction. So that brings us to that point here. So the vector we're looking for is that one there that goes there like so. So that's vector A. Alright, so there's part A. Drawn that. Part B, find magnitude and direction. Alright, the direction we're wanting is that angle there, angle theta. And so our magnitude of A is the square root of 3 squared plus -1 squared. Root 10, and our angle relates to theta, tan minus 1 of y over x, so that's tan minus 1, -1 over 3. And so it makes an angle of -18.4 degrees with positive x-axis. Okay, so that's it for a single vector, and of course we can do all sorts of other things with the vectors as well. Alright, so here we've got two vectors, A and B. A is 3i plus j and B is -2, that's supposed to be I, plus 5j, that's supposed to be a j. We want to find A plus B, so A plus B, simply 3i plus j plus -2i plus 5j. And we simply add each of the components. So for the I component, we add those. So 3 plus negative 2 is 1 I. The j components, we add those. So we've got 1 plus 5, which is 6 in the j for that one. 2a plus b, or take b I should say, we simply multiply vector a by 2 and then take away that, so that's 6i plus 2j. From that we're taking away negative 2i plus 5j. Alright, so we've got 6 minus negative 2. 6 plus 2 is 8i. And then we've got 2 minus 5, which I think is negative 3, in the j direction. Okay, one more example. Alright, there we go. We've got two vectors, OA, which is 3i plus j, and OB, which is negative I minus plus 4j. And we're asked to draw them. So here's our Cartesian. So the first one, OA, 3i plus j, is point A there, and so there's our vector. The next one is OB, which is negative I plus 4. There's that point there, so there's our point B, and so our vector, goes like that. Alright, so there's that. So that's part A done. Part B is asking us the vector of A to B. So there's our vector A to B, that green one. And so what we need to do is we need to come up with an expression. Now remember, these things add in head to tail. So the ones that are oriented head to tail, there's a head to tail orientation. The other two at point O, our origin, and B, well, our origin's got two tails together and B has got two heads together. So they don't add. So what adds is OA adds with AB to give us OB. So that means that AB then is OB take OA. So that would be negative I plus 4j take 3i plus j, like so. Alright then, taking our components, negative I take another 3 is minus 4i, and 4i take an I is a j, I should say, not i's, they're j's, is 3j, and so there's that one there. Alright, part C, so that's part B, so part A was that diagram, part B was this one here. Part C, M is the midpoint. So midpoint, this spot right here, there's M. Okay, so what do we know about that? Is that OM, we're told, is the halfway point of AB. But when we go back here, what we're after is we're after the vector that goes from the origin to there. So that's the one that we're after. So what are we after then is to get there. There's a couple of ways, but one of them is to go from O to A and then to M. Alright, so what we know then is the vector O to A plus the vector A to B is the vector, oops, not A to B, what am I talking about? A to M is the vector O to M, and that vector O to M is what we're after. But what we do know is we're told that M is the midpoint of AB. So the half of AB is there. Okay, so O to A, if we just go back, O to A is 3I plus J. So we've got 3I plus J plus a half of, oops, wrong way, half of, there it is down there, AB minus 4I plus 3J. Alright, and then we've got to do our sum. Okay, 3 plus a half of negative 4, so that's 3 minus 2, which is 1. I. J plus a half of 3, so that's 1 plus 1.5, which is 2.5, which is 5 over 2J, is equal to O to M. Alright. Okay. So here's our I and J. So really I and J is just the X and the Y components, nothing more than that. Alright, so that brings us up to exercise 3D. That's problem set number 4 on your sheet.